Yo, 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 what's happening, Webster? This is Wave Energy Goal 6, and in this goal, students are going to be able to classify objects based on how they react to light, meaning translucent, transparent, and opaque, and you're using vocabulary correctly to explain how light behaves when it strikes a surface. Going beyond that, you're able to demonstrate understanding of how to use different mediums to manipulate light. Here we go. So, three types of objects when it comes to interacting with light. Objects can be translucent, transparent, and opaque. These are really the vocabulary words for this goal. Words you will need to know. So, what makes an object transparent? Well, an object is transparent when it has the ability to let certain wavelengths pass through them, and objects can be clearly seen. They transmit light. So if you check out this canoe, light is clearly passing through it, and so it is a transparent object. Examples of transparent: glass, acetate, and water. But water really only in small amounts, and we will talk about why a little bit later. So those are examples of objects that are transparent that allow light to clearly pass through it. Picture time! Alright, so what happens with transparent objects is that light rays go in and they pass through the object. They directly pass through the object, or it transmits light. What makes an object translucent? An object only allows some colors of light to pass through, but not others. For example, the stained glass. Okay, in this part of the stained glass, it's only allowing blue light waves to pass through, and all others are absorbed. An object can also be translucent if the material lets light pass through, but cannot be clearly seen through. It diffuses or scatters light, like this window. Okay, you can tell, yeah, something's over there, but you can't clearly make out the shape through this part of the glass because it's translucent. The light is being scattered as it moves through that medium. Examples of translucent: wax paper. If you try to look through wax paper, it scatters light. You can't clearly make out the objects that are on the other side of wax paper. Frosted glass, lots of water, and tinted windows. Picture time. So, in translucent objects, the light ray goes through here. Okay, light ray goes through, and then it kind of scatters, so light doesn't travel in a straight line as it moves through the object. It goes all different directions, and some of it could even be reflected. So not all of the light is making it through that translucent object. It's either being scattered or reflected. What makes an object opaque? Not opaque, not opaque, opaque. Materials that absorb or reflect all of the light are opaque. They do not let the light pass through. Okay? So simple enough, objects that don't allow any light to pass through. Examples of opaque objects: a book, a wall, a door, a desk, a tree, your head. All of these things are opaque objects. Light cannot clearly be seen through it. It blocks the light and then reflects light. It reflects light. It can reflect a lot of light, like if it is a mirror, or it can only reflect some wavelengths of light, like if you're looking at a colored object, it's only reflecting that color, that wavelength. Picture time. So in opaque objects, the light ray goes into the object and is absorbed or reflected. So in this object, almost all of the light waves are absorbed except for the color of the object, and those colors are reflected. In a mirror, all of the light is reflected and none of it is absorbed. And both of those are opaque objects. They do not allow the light to pass through. Exceptions to this rule: a very thin sample of an opaque object can be translucent. I think of like sheets of paper. So you have one sheet of paper, you may be able to see writing on the other side of that paper. If you keep adding sheets of paper, it's going to eventually become opaque. Adding more layers of a translucent object can scatter the light more and more until it is all reflected, scattered, or absorbed, making it opaque. Alright? So that's the real exception to the rule. Why is the ocean bottom so dark? Well, it kind of goes back to adding more and more layers of translucent objects. So sunlight can only penetrate so deep. Water begins as translucent, but as you go deeper it becomes opaque, scattering all of the light at the deepest depths, and we get kind of eerie, creepy looking creatures at those deepest, darkest depths. But as translucent water layers are added, more of the light is absorbed. So in all opaque objects, some light is reflected. In objects that have a color, all of the wavelengths of visible light, white light hits the object, but only red light reflects off the object for red objects. So whatever color you're seeing, that is the color that is reflected into your eye. Alright, two examples of green rooms here, but totally different way of getting to it. So in this picture, there's a green light that is being reflected off of the material. Now, is all of the stuff in this room actually green? Probably not. It's probably white, but it is reflecting green light because that's the only kind of light that it's being given. If it was given white light, then it would reflect all of the colors of light. But it's only being given green light, and so therefore it only reflects green light. On the other hand, in this green room, the walls and the floor are all green because when light is shown on the green, it absorbs all the other colors and only reflects green. So two different ways of getting to green, either green light or green objects. And depending on what's happening, you can both get green. Kind of crazy, but very cool. This is how it happens on a stage, where we know an object is not actually colored, but they use a colored light to change what that object looks like. Alright, well that's it. Enjoy the video on your way out, and we'll see you in class.
So we've got some examples here of the different types of color. This is the one you're holding up right now is an opaque color. Right. Okay, it's medium magenta. And as you can see, we painted the color on top of this black stripe to show you that opaque colors totally obscure everything that they're put over. You can't see the stripe.
Good color, good hiding power.
Good hiding power.
Right. I had this happen in my studio recently. Reached for a tube of paint, and I picked up a transparent mixing white, and I didn't realize I had it on there.
And you were looking for an opaque color.
Yeah, I'm trying to figure out why is this not covering. So
Well, this is a good point, actually. How do you find out, whether
you read the tube,
right?
baby.
You read
There's
the
a
tube.
lot of information on the front of the tube. It's got it right on
It's going to
there.
tell you right on there
It
that
says
it's opaque.
Yep.
Okay, great.
Absolutely.
So let's move over to translucent,
Yep.
which is sort of in between transparent and opaque.
For the middle of the road.
Middle of the road, this is deep violet, again painted on top of the black stripe, and you can see that now you can see the black stripe through the color layer
Yep.
a lot better than you can through the opaque
Right.
layer.
Which is different than obviously the last
The
one.
last one, which is transparent. Okay,
yeah.
this is quinacridone magenta. Again, on the black stripe, you can really, the black stripe is really starting to affect the color layer on top. You can really see that black stripe through. And we were talking about this. You were saying you go back to color theory.
Yeah, you went to color theory days. If you're an art student, if you had that, it reminds me of color theory, where this has become a totally different. It's optically mixed on there. The square in the center is totally different.
Totally different.
Yeah, and then we finally got some. We moved from practice really, or theory rather, to practice.
How would you use the differences in these colors?
Exactly.
Okay, so you're holding up